All right, you guys. I just recorded this whole video, but there was a problem with it, so I'm re-recording, and I have a class in 14 minutes, so I'm going to be moving kind of quick, but you guys can pause. It's all good. So, this one says to find the derivative of this two different ways. The first way I'm going to do it is with a chain rule with a little product mixed in it. So, chain with product. This will be derivative of the outside with the inside untouched times the derivative of the inside. But the derivative of the inside is a first d second plus second d first. And then we have a whole lot of cleanup to do. So first thing I'll do is I'll make this just the big denominator of everything. And then up top, any negative exponents and stuff, I'm going to kick downstairs. So this becomes e to the x over 2 square root of x. And then I'm going to do plus square root of x e to the x all over 1. Why did I put it all over 1? Because we're going to need to do common denominator to smash all these fractions together. So this is going to have to get hit with a 2 root x over a 2 root x. Then I'll leave the big denominator alone and just simplify the top. So the top, let's see, when I multiply root x with root x, I just get x. All of those, both those fractions now have the same denominator, which is 2 root x. And then on top, we'll get e to the x plus 2x e to the x. Now I am going to factor this e to the x to the outside on the top, and you can think of the bottom like its own fraction. So to divide by fractions, you keep the top fraction and multiply by the bottom fraction upside down. Top fraction, I'm factoring out the e to the x plus 1 plus 2x, and then all over, I can get it horizontal, there we go, 2 root x times 1 over e to the x root x. Now I see that this e to the x and this e to the x cancel each other out. And then we get 1 plus 2x all over 2x, because the square root of x is multiplied. And you just get x. So this is what? Y prime? This is the derivative. But that was just one way to find the derivative. We're going to find another way. When I look at this, I see a natural log with two things being multiplied. And there's a property of logs that says this. If you have log a times b, you can split that apart into log a plus log b. So I'm going to do a whole another approach, but with log properties. So if I split that log in the beginning, like not doing a derivative, I'm just splitting it up into natural log e to the x plus natural log x to the 1/2. Notice I changed the square root of x to the 1/2 because there's another property of logs where if you have a power on an argument, that gets to come out front and be a multiplier. So those get to come out front. So, still haven't done a derivative. I'm just going to do x ln e plus 1/2 ln x. Now, the natural log of e is just 1 because e to the 1 power is e. Just spiral your log. I did it in the other video. So still have not taken a derivative. I'm just simplifying that that's x times 1, which is x, and then we get plus 1/2 ln of x. Now I can take the derivative. The derivative of x is just 1, and then the 1/2 hangs out in front, and the derivative of ln of x is 1 over x. So then we get 1 plus 1 over 2x, and then do a little common denominator work. You get 2x over 2x plus 1 over 2x. So this y prime is equal to 2x plus 1 over 2x. Now, let's look at what happened. Notice that these two things are the same derivative. Now, which one do you prefer, you guys? Do you prefer all of this good algebra on the left? Yum, yum. Or do you prefer a little bit of log properties from Christmas past and then a very simple derivative? I'll let you make the decision. Find the derivative of y equals square root of sine of 7x using the chain rule twice. Now, the chain rule twice is because if you rewrite this, there's an inside function of sine of 7x and then all to the power of 1/2. But then there's another function nested inside the sine. So it's like functions and functions and functions. Chain rule. Derivative of the outside with the inside untouched times the derivative of the inside. The derivative of the inside would be cosine of 7x, but it's another chain rule because of this 7x being nested in there. So derivative of the outside with the inside untouched, and then times the derivative of the inside. So if I clean things up, like put negatives in the denominator and all that, we will get 7 cosine 7x in the top, and in the bottom will be 2 sine 7x. Oh, but that's the square root of that. So let me... Would you like that sound effect? What happened? Sine 7x. There we go. Chain rule twice. It actually wasn't that bad. Find the slope of the tangent to y equals that. So when I'm seeing that function, I'm thinking chain rule. Slope of the tangent means we just have to plug something into the derivative. So chain rule, derivative of the outside with the inside untouched times the derivative of the inside. That's basically your derivative. No need to try it. Well, you can't really clean it up with algebra, but now we really just have to plug in an x equals 2 to figure out the slope. So this is e to the 2 squared minus 2 times 2, all times 2 times 2 minus 2. So many 2's. Let me see, that's e to the 4th minus 4, so this is e to the 0, and then 4 minus 2 is times 2. E to the 0 is just 1, so this whole thing is 2. Find the equation of the tangent. Oh, now the equation, not just the slope, but that's the y equals mx plus b. Here we go. Pop that derivative. It's chain rule. Derivative of the outside with the inside untouched times the derivative of the inside. And then we need to figure out what's going on with that derivative at 0. So I'll plug in a 0 to find the slope of the tangent. So in the bottom, we just get 1. So I think this whole thing is just -3. Sounds right. So that means our equation is y equals -3x plus b. I don't know the b value, so we need to plug in a point. So if you take this and plug it into the OG equation, we can figure out the point. Y equals ln 1 minus 3 times 0. And then you get y equals ln of 1. Now, natural log of 1 is 0. Here's why. If you think of natural log as log base e of 1 equal to something, if you spiral this, like e to the what gives me 1, and you think e to the question mark is equal to 1. Sorry, that's an e. The only way to raise something to a power and get 1 out of it is if e is 0. So that whole thing is 0, which means the coordinate it goes through is 0, 0. Then if you plug that into your y equals mx plus b, you get 0 equals -3 times 0 plus b. Wow, this is boring. It's just 0. So the equation equals y, the equation of the tangent is y equals -3x. Find the slope of the tangent to that. It's a product rule. So now we're just finding slope again. So y prime equals, or not y prime, sorry, f prime of x. Not that it matters. First d second plus second d first. And then we got to plug in a 1 to find the slope of the tangent. So we get 1 cubed 1 over 1 plus ln of 1, 3 times 1 squared. Nope, not there. The square goes there. This whole first part is just a 1, and then ln of 1, that's e to the something equals 1, so that's just a big 0, so that kills everything. So that's 1. Find all the stationary points of that. This is going to be a photo finish, you guys. Stationary points are when the derivative is equal to 0. So let's do quotient rule. Low d high minus high d low over low squared. So low d high minus high d low all over low squared. I'm going to factor an e to the x out of that, and we'll get x minus 1 minus 1, so that's x minus 2. So that's the derivative, but then I got to I got to set that equal to 0 to figure out where the stationary points are. Multiply both sides by the denominator to get rid of the denominator, so you get 0 equals e to the x times x minus 2. Now you have two things being multiplied to get 0, so the same way that you factor and you split them and set them equal to 0, like with quadratics, you do the same thing here, that both of these are equal to 0. Now, this first part doesn't have a solution because there's no way to raise e to a power and get 0. Like, think about it. Like, e to the 0 isn't 0, and negatives don't give you 0, and positives don't. So this part is no solution. But this part does have a solution. X is equal to 2. So then the question is, well, it said find stationary points. So I'm going to have to plug that into the master equation to figure out what the actual coordinate is. So this is e squared over 2 minus 1. So this is e squared. So the coordinate is 2 comma e squared. But then the question is this a local maximum or a local minimum? The way you do that is with the second derivative. So I don't have enough time to show you, but what you're going to need to do is find the second derivative, which is going to be a quotient with a product. Yeah, because in the top it's like two things being multiplied. And then we'll feed in an f prime of 2. And if this is bigger than 0, that means that the concavity was positive. It's opening up, which means it's a local min. And once again, not actually doing it, but if f prime of 2 is less than 0, this would mean that it has negative concavity and it's a local max. So I apologize, I didn't have time for that last step. Finding the derivative of this is a little bit of some algebra for sure. But if you're curious about how to do it, catch me in class and ask a question, please. Ignore that.